Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's biweekly contest, find score of an array after marking all the elements. The problem is bit easier than the usual medium level problem of lead code, but yet let's discuss about the problem. So the problem states that you are given an array nums and you will start with score equals to 0. Now you will choose the smallest integer. If there is a tie, you will choose the one with the smallest index. So let's say there are two integers which have same value, you will choose the one which has smallest index. Now, whatever element you have chosen, you will add that value to the score. You will mark that element and also mark its adjacent element as well, both left and right. Now you will repeat these steps until all the elements of the array are marked, right? Now, after the algorithm terminates, score would have some value and you have to return that value as an answer, right? So let's take an example. Let's say this is the array. Now here we will just choose the smallest integer. Smallest integer is 1. Now there is only one 1, so there is no tie at all. But let's say smallest integer was 2. So and there are two 2's, we will choose the first one because first one has smallest index, right? So here we'll choose 1. Now after we choose 1, we will mark both its adjacent element. So we'll mark 2 and 3. So all 2, 1 and 3 are marked. So all 2, 1, 3 are marked. So unmarked elements are 4, 5, 2. Now for unmarked elements, again we'll choose the smallest integer. Smallest integer is 2. We'll mark its adjacent element. Adjacent element only contains 5. There is no right element, so we'll just mark 5. So now marked elements are 5 and 2. Only unmarked element is 4. So we will pick 4 and just mark it. Now what we have chosen, we have first chosen 1, then we have chosen 2, and then we have chosen 4. So the score would be 1 plus 2 plus 4, which is 7. And hence 7 is the answer, right? So this is one of those problem where you don't need to devise the algorithm by yourself, right? You just need to figure out the right data structure that you will be using to solve the problem. So let's discuss a bit. So these are the criteria. We will have to select the smallest unmarked integer, and if there is tie, we'll choose the smallest index, right? So of- what this exactly means? It means that we will, if we just maintain a pair of value comma index, then we need to just return the smallest pair which exists, right? So basically what they are saying is, if there are two values which are same, we have to break the tie with the index. So that's where we maintained v comma I pair, where v is the first one, so we'll just compare with the first one, like the first element first. If it matches, like if there's a, if there are more than one element with the same value, then this index will be used to break the tie, right? So basically we will convert the array into value comma index format. So the this given array would look something like this, right? So now we have to select this, like we have to select the smallest one always. So we'll just sort the array. So what we have done, we have said, okay, 1 comma 2 is like 2 comma 0 is one pair, 1 comma 1 is one pair. This should be one, right? So 1 comma 1 is one pair, 3 comma 2 is another pair, 4 comma 3 is another pair, 5 comma 4 is another pair, and 2 comma 5 is another pair, right? So we just maintain this list and we have sorted that. Now the algorithm is simple. Just pick the smallest one and then remove its adjacent element as well. So we'll remove this 2 and this 3. So this 2, it means 2 comma 0, and this 3, it means 3 comma 2. So we'll remove these two elements, right? Now after this, we'll again, like this is also removed, right? Because we have chosen 1. So score is now 1, right? And now we we have left with 2 comma 5, 4 comma 3, and 5 comma 4. So the first element is 2 comma 5. We remove that, right? And if we remove this, we have to remove the adjacent one as well, right? So we remove 5 comma 4 as well and added 2 into the score. Now finally, the first element that remains is 4, so we'll just remove 4 and add it to the score. So there is no adjacent element which are unmarked, so we'll not do anything. So basically, we have to perform two operation. The operation is get the smallest value comma index pair, right? So given a set of uh, elements, get the smallest value comma index pair, right? And we also have to remove the element. So the data structure that we will be using to store this list would be able to perform these two operations efficiently. So we can perform these two operations in order and time anyways, but order n would not work because number of like the length of the array is 10 to the power 5. So what could happen in the worst case is you are always removing one element, right? So let's say you always choose the last or the first element, so you in that case you will be always removing two element in the worst case. So basically number of operations that you might take is order n, and hence this n square solution would not pass. So you need a data structure that can give you the smallest element and can also remove an element as well. So these two operations that data structure should be able to perform in order log n time. Now I would encourage you to pause the video and think about all the data structure that you know of and which of the data structure you can apply here. So hope you have thought about it. The data structure that would give the smallest element and also remove an element is set. So we can use set or any sort of balanced binary search tree that would be able to perform these two operations in order log n time. Now notice that here we can't use priority queue. Priority queue also will give you the smallest element in log n time, but it can't remove any element. It can only remove the smallest element from the priority queue in order log n time. But here we have to remove any element. So that's where priority queue here would not help, right? So we have to use set here, right? So I would now encourage you to pause the video and try to code this solution yourself. I am not showing the pseudocode intentionally so that you just use set to maintain this list and just perform these two operations that you have been given and solve the question. Now hope you have at least tried coding the solution yourself. So let's look at the code. The code is exactly the simulation of the problem. What we have done, we have maintained a marked array and we have maintained a set, right? And set contains value comma index pair, right? After that we will just keep on applying the algorithm until there is at least one element which is not marked. Now the smallest index is something which is at the top of the set, so we'll just take the first element of the set and find its index, and we'll remove that element as well. Now score would be like for score we just add the value of that index and we mark that index as well. Now after that we have to mark its adjacent element as well. So for that we checked whether it has a right element or not. If it has a right element and it is not already marked, we will mark that element and also remove it from the set. Similarly, we will check its left element if left element exists. If it exists and if it is not marked already, we'll mark that element and also remove it from the set. So after performing these operations, score would contain the sum of all the selected integers, and that's what we want, and we will just return that score as an answer. So hope the problem is clear. If you have any doubts in the solution, please post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.